Good now. Are you guys with me? Yes, right. Enjoying the meetup? Going good, right? Yeah. So, all right. Welcome you guys on for this talk. Right. My name is Manish. Manish Jhanwar. It sounds like a Jhanwar, but it's Jhanwar. Okay. And it's silent. That's a family name, so I can't omit anything. So before we start, right, guys, let's have a huge round of applause for our speakers, right, who spoke for the day. It takes a tremendous amount of efforts to come onto the stage and speak. Not easy. Not easy, guys. Even for 10 minutes, if you tell me, even though this is my close to maybe 100 talk, but still, whenever I come onto the stage, I shiver. I shiver heavily for the first 5 minutes. Right? So, and the second guy with whom I really want to thank, one guy who does his job very beautifully, and because of whom we guys are all here. Right? Kiran. Big round of applause for him. Thank you, guys. I mean, he's doing it consistently from close to 10 years. This meetup, right? Single man. Not easy job. Thank you, Kiran. All right, guys. So coming back to our talk, right? Uh, what we are going to do. Okay, let me cover it up. Before I even start with my talk, right? And what I want to discuss with you guys is about this meetup community, what we do normally in Bangalore. Especially in Bangalore, it's getting very popular because maybe the kind of crowds, right, or the people, the excitement that people have here in Bangalore is far bigger than any other cities that I see in India, right? So a big hats off to you guys for being here on Saturday and attending this talk, right? Thanks everyone. So I keep talking with a lot of people offline to understand why people still come on to the meetup, right? Where I don't see that happening much in NCR or in other part of India, right? And when I spoke with few of folks, just casually I spoke with one of the person, okay, that why do you attend this meetup? I was expecting him that he's going to tell me that, yeah, Manish, I come here for a networking, or I may come here for a free food, or I come here to make friends, or I'm looking out for a job, right? Something like this. But you know what that guy told me? I was really amazed with his answer. He told me, Manish, I come here to make better use of my time, right? Very strong statement, if you ask me, right? We all have a limited time. What we do, how we use our time is how defines us, right? So you guys made a good call of, even though it's Saturday, right? It's everywhere. It's a mall culture in Bangalore, but still you guys are here to learn the tech. That shows the dedication and how effectively are we using our time, right? So thanks, guys. So let me quickly get into what I'm going to cover up, right? So I'm here for a talk on basically about using Golang, right? Golang is a programming language developed by Google, right? And this is so you have a Golang setting out in one part of the tech stack. You have an Android, which we use every time, and then you have a React Native, right, where you create iOS and Android apps, right? So I'm going to merge all these tech here because that's what I'm really good at. I do not know the tech at very deep level. Even any tech, I do not know at a very deep level. Probably you guys may know far better than me. But what thing which I know very well is how the whole software architects works, right? I do not depend on any one particular language. If you ask me, I really do not know any language in detail, right? So the here what we are trying to do is basically how do we compile these three different tech stack and create a use case for us and figure out does it really fit for us or not, right? So the first point which I'm going to take you is Go compilation. The second one is Android architecture, right? This is a lot of us may be aware, may not be, but this is what something which will help me to set the stage, the context here, right? So this is what I want to take. And then you have a CPU architecture. This is one of the very basic stuff which I see when we talk about mobile phones. People do not talk about CPUs here, right? And everything that you do on mobile phones or on web depends on your CPU. So where is the CPU talks going away? Right? Maybe we have taken it for granted that CPU works as intended, right? But how does the software on the CPU sits is what my area of interest is. So that is what something I wanted to set here in this forum. And then React Native architecture, which you guys will know far better than me. But to connect those tech stacks here, right? I'll take you through how does the internally it really works. And go with Android, right? This is the complete code. I'm going to show you only the working code, no live code. I'm very bad in doing live code. Whenever I did a live code before, every time Wi-Fi never worked for me. Okay, so I stopped using. I just show the working code snippet, right? And okay, this is about me. Who am I professionally, right? I am basically a mobile specialist, if you call me in a proper professional term, right? I understand Android, React Native, React, Flutter. I mean, you call it. I do understand at the top level. I may not know all the syntax of Dart, JS, React, but I understand how does the whole architecture fits in, and how do I make myself fit into those architecture, right? And then okay, yeah. So this is what I have a tech experience of 14 years, all into deep level code. I code. I'm a hardcore coder. Okay, I code. I only very recently, from last 2 years, is when I started talking about my code. Others, I am a hardcore deep code, right? And my all 14 years, my most of the experience has with Samsung is what where I stayed for 10 years, right? And one of the beautiful company which I still misses, but the change is always good, right? I mean, today's folks, if you see, every 2 year we change company, right? And I come from a generation where we prefer to stay with one company. But it's all pros and cons of everything you say. For any company where if you ask me personally, right, I look out only for three qualities in a company. Good money, the first, right? Good people who are smarter than me in every part, what I do. Let it be in terms of IQ, let it be in terms of EQ, right? People who are smarter than me. And third thing is learning, which makes a lot of sense for me, right? As long as we are learning while being in any company or by switching, it should be able to help you, right? And my most of the experience has been in a browser. So this is where I come from. It looks like a single app, but that's the product where 140 folks work. Okay, so it's a huge product for a lot of companies, and we still use it in all our Samsung phones, right? And currently with Walmart, I work for WMS. Any idea, guys? What does WMS stands for? Very popular in supply chain tech. I'm sure at least one person will be able to answer. No? Okay. Sorry? Sorry? No, I can't. Okay. It's WMS stands for Warehouse Management System. Right. That's it. That's the inventory way of how does you manage the inventory across e-commerce, right? This is the way team where I work for. I have coded across, as I said, right? I do not know anything in detail, but I have coded across as and when the business demanded, right? Recently, I started coding in Go. Go became a great attraction for me, is because first of all, when I attended, I was seeing one of the Golang video, okay, and one of the stakeholder, right, from Google developer team, in that video, he said that Golang is a language which I can challenge you that you can learn in just 24 hours, right? Just 24 hours is what it takes for a typical developer to learn Golang. And I when I digged into it, I realized, yeah, it is less than 12 hours for me. So it's as easy as that. But somebody tells me to go back and code in C++ or C, I still find it tough. Right? Go is as easy, even though it does the same job as what C or C++ is doing. That means converting into the machine code, compilation, normal source code into the not byte code, into the exact machine code, zeros and ones, and then making it run on a processor, right? And okay, this is just about what I do day to day. I enjoy playing TT and Sudoku. This is my okay. Here comes, guys, one of my highly controversial slide. Okay, the way whenever I speak onto this, okay, a lot of forum, this slide end up taking 40 minutes. A lot of people backfire me on this, that Manish, you are not supposed to speak this. But I still go ahead and speak about it because we are here in a community, and it's my duty to make sure that somebody who has spent a decade, more than a decade with IT, how does the IT has actually worked for us? Right? There's nothing wrong in it. It may work. Each one of us have a different journey, but I'm just going to give you a glimpse of what did I learn. Right? The first one, which I usually say, is always be real and humble in IT. Guys, IT industry is something which each one of us will agree, I'm sure, that all our superiors or the people at the leadership want us to change. When I say change, to make extra stretch, right? To work for longer hours, to code heavy, to get the use case on weekends. Each one of us, right, are being tuned in, especially in India, I see very common that the extra hard work or working longer hours is being rewarded. That's not something which I still value. So what you have to do, if you know you are right in what you are doing it, keep doing it. We are being paid to get the job done rightly. Okay, and keep doing the things which are right for a project, but not at the stake of your health. And the second one, right, value time. So this is where I was saying controversial for me. Okay, now value time literally means in an IT industry. Okay, the typical career tenure that I see in IT industry is so small for a lot of us here that it amazed me that people at today's generation think IT is extremely shining and glimmering. It's not. The time that which I have seen in my corporate right life is typically 18 years. You have a time of standard 18 years of being in a corporate. Now, you may ask, how did I get into this 18 number? I never heard. People told me 30 years. People told me 40 years I can stay. But is it really happening? Look out in your own company. Are you seeing a guys of 40 years, apart from one or two, or four, five, six folks, right? Not in double digit also. Are you seeing those guys? Where those guys have disappeared? A lot of people who go silently, right? Remember, guys, when I say this 18 years, I'm just talking about the typical average IT folks, not the exceptionally. So if I just categorize IT workforce here in India, I say 70% of us are average folks. 20% is the real cream. And probably the 10% is something which may even no go more than 5 years in IT. They go off from IT given the pressure. Right. So I'm talking about the middle graph here. 70% of us, the typical corporate development tenure is 18 years is what I'm seeing it. A lot of people may disagree. Do you disagree, guys? Any one of us? What I'm saying is, do not buy the? Oh, so everyone agrees. This is very surprising. I never saw an audience where everyone agrees. Anyone who want to say that Manish, no, what you are saying is a crap. I have seen people working for 30 years in IT, in a engineering team. I'm talking about engineering teams in IT. I'm not talking about product management. I'm not talking about E2E testing teams because I do not come from E2E, so I have no idea. I'm just talking about engineering teams. And when I say 18 years, it literally means the best part of your career. Right. So first 2 years when you start your career, 2 years are always struggling. Agree, right? You are going to learn. You are learning the tech. You are learning the people. More than tech, we always learn the people. Right. And then from 3 to 14 or 15 years, life become very easy. Right. You know how to handle the people. You know what is agile mean. You know how to handle get the job done. Right. You know a lot of stuff. So life become easy. The moment you crosses 15 plus, right. What I have seen typically, lot of superior senior leadership expect you to know a lot of things, which if you know well and good, but if you do not know, for them, a senior a senior architect means anybody who is able to code in anything, in typical words, in a good IT company, right? So for me, this is what I'm seeing, and how did I get into 18 is because I spoke with a lot of people on the ground. This took me typically to understand this number, right? In India, it took me 5 years to actually realize what's been happening. Now, what are the reason, right? Why the tenure for us is so less in IT? Sorry, anyone? Why our time span is less? What will be the possible reason? Be- be-
Because of the reason like technologies are day by day changing and changing, and we always need to
Perfect. Yeah, because the technology has become very mature. If I take 15 years back, come to COBOL mainframe server, people were really excited because they did not know anything. But now nobody is really excited about a tech apart from few folks genuinely, right? Nobody is really excited about tech. What they are really excited about is making money from the tech, driving the business, right? So the tech has highly matured. So number of people is what this is, guys. This is just purely my understanding of tech. This does not represent any of the IT corporate views here. It's just what I see on the ground. So why am I telling it to you guys? right? So in the community, especially since I have seen these communities growing from last 10, 15 years, right? And I realized that no, people talk about tech, but people do not want to talk about the dark secrets which happen in IT industry. There are a lot of folks, guys, who silently goes away from corporate, right? So here I'm just talking about your IT job in a corporate. I'm not counting your inherited wealth. If in case if you get a wealth from your family, that's a different story to me. You will make more money than me, right? What I'm talking about is your normal corporate IT career, right? So why did I say this here? Just to make you guys aware that plan your finances, right? Plan all your XYZ money problems in that 18 years. So that at least, see, we all want us to go longer, right? But what I'm talking about is a struggling problem after 18 or 20 years. So plan your finances so that you can be aram se independent out of those things. And if you stay longer, well and good. And another disclaimer here, just quickly. This is only for IT context. I am not talking about US. I'm not talking about Europe. I'm talking about Australia here because what I'm talking about just being in Indian context. The reason one, what you said, right? The tech has become highly mature. Second, the concept of demand and supply. It's a business, guys. Tech is a business. We are here to make money by doing a job. Business is doing their job to get the money out of us, right? So it's always demand and supply game in India. Each one of us, we all know, right? Each one of us want to get into IT. And in engineering, when I went to engineering college, right, just to have understanding of how does the new guys understand, each one of us just want to get into IT. And when I talk to them in offline forum, they say, sir, this is the only industry which allows me to bring my standard to upper middle class. Right? In India, we do not. So it's very true. But is it really going to happen going forward? Is what I'm questioning it. Yeah, anything here? Yeah.
Hi, Manish. So first of all, thank you so much that you're putting your corporate lesson with us, and after having a decade of experience, I especially, in my team as leading my team in Genpact. So what I suggest my team, at least you give 1 hour for your health, and then you will be more productive. At least, whatever work you are doing, whatever pressure you are having, just take out and give 1 hour for your health. Do yoga, do for fitness, go for gym, play cricket, play badminton, whatever do, but do at least 1 hour for your fitness. So that will make you only healthy, not for your manager or your team. So that's a good thing, I think. Thought so.
That's a wonderful thing what you said, right? Taking care of employee well-being. But we all talk about it. Is it really happening on ground? Ask yourself, guys. Is it really happening? I sure you probably are a good manager who is trying to take care of it. But I'm just trying to question here for an average folk. Does in their team are they see that manager really is happy when there's no work? Then he talks about mental and health wellness. But the moment I get a business, I get a production bug, I do not give a damn care here. The what thing I really care is about getting my issue fixed. Right? Harsh reality. So, right. So just value your time and understand this thing and value money. Why value money? Because you have a limited time. You typically have 18 to 20 years of lifespan, a great lifespan. You may have more than that, but I'm just talking about the good lifespan. So make your money the most, even by staying in the same company or changing. Do what it takes. IT is no longer going to the same what we have seen in the past. I have seen my leaders, say, passing out in 1998, that tenure, they made huge money. Did I make money? No, I did not make money. Well, my juniors are going to make money. I still doubt that. As long as you are in the top 2%, you're going to make money. But if you are a general folk who comes in that 80% category, I question that. While being in India, if you get an on-site and all, that's a different story for me. Make in dollars, that's a different story. In Indian rupees, will you be able to make money? Right? Just think about it. Right. And the last one, where I see that this is for me, guys. Okay. By telling you guys, this is for me. I keep reiterating that value your parents or the near and dear ones. When we are in the business and all, right, we do not much bother about the real people, right? Value them. We have less time with them, right? I mean, far lesser time than what you think of, right? So, yeah. So right before I get into the next slide and the technical part of it, I just want to make. So the whole agenda for this slide was so that I get a promise from you guys that after going home, right, you will think about it, right? You will realize the value of a money. You will realize that I have to plan something for myself, be it a passive income source, be into the stocks, bonds, what it takes. But you will have to save, invest, and make money. A need of the hour. This is not an add-on, guys. If you are a self-bred earner, right, in your family, and you do not inherit any family wealth, okay, and you are saying that I am solely depend on IT job, then you have to play your cards very wisely, right? Just be aware of it. Think about it. No answer, no LinkedIn comments, nothing. I don't need anything. Just think about it, right? Do you all promise me that you will think about it, right? Please do that, guys. It's a need of the hour, right? So, all right. This forum turned out to be pretty coolest of all. Okay. Uh, so, do you guys feel that I made a mistake of showing it here? Anyone who feel? Because I'm more interested towards pessimistic, not pessimistic, slightly negative views for me, which helped me to figure out why I shouldn't show this. So when I talked about this slide with my leaders, okay, I got a very mixed response. They said, Manish, you do not show this slide on your forum. I said, Kyon? Why? He said, Manish, Indian society is not being tuned to hear criticism about their professional world in a public forum. I got that answer. I said, why? He said, yeah, we are not tuned to hear about our professional careers. But we have to, guys, we will have to understand that. I see a folk making 2 lakh and 1.5 lakhs per month is his operating cost. That's not acceptable to me. If you're making 2 lakhs and saving nothing, right, what is the point of it? Just to give you a simple calculation, saving 50K per month for 16 years, okay, at the rate of 7.5% will just get you 2 CR. That's a simple max. So save 50K. I know it's very tough. For first 2 years, I agree, you will not be able to save. But the moment you grow in your third and fourth year and you get out of your education loan or some XYZ loans apart from home, right? Make money work for you. And that is what my plan is. Okay, so it's not just about I'm just saying it, I'm actually doing it on the ground. And I would have been very happy if people would have told me before when I was 1 or 2 years in the industry. Nobody told me about this. I thought I'm going to stay here for 30 years. Luckily I have been blessed enough where I have been in the top 2% of Indian IT labor. I made a lot of money, okay. But the fact of the matter is I spend it heavy because nobody told me that will I have a job at that stage of my career, right? So just think about it. Okay, let's get into the main talk. I have highly debated, okay. So what we are talking about is basically how to go to go on Android with React Native, right? This is a very vague and faltu statement, but yeah, let's get into. So brief about Go. Who has created it by Robert at Google in 2009 is when they started working on it and pushed it into the prod. Statically typed, right? Go is a superb language. Just try in your free time, guys. You will enjoy it. It's a supremely beautifully crafted language. That is, I personally loved it just because of its ease of use. Highly simple. If I have to write, so initially somebody used to say me that Manish, if I have to traverse across Python, say 1,000 files, what code will you use to traverse? I used to code in Python and get the job done, but now I stopped. Now I code in Golang to get the same file processing or the basic stuff of system level programming. And it's very easy. You have a good support on the net. So anything you can Google it out. It's a compiled programming language. That's the best part of it. Not being interpreted just directly. Throw the source code, compiler takes it, get into the assembly language, get into the final object codes, make it run. Right? Same as C++. Very close to object. It's not exactly object-oriented programming, but very close to that. Great concurrency support, so every thread and all the pretty standard concept of any programming language is being supported in Go. Very fast. In fact, that's the best part of it. What I like, right? When I play with files, say for example, 10 TB of files in my system, and I want to navigate across, right, and get some processing on files. Go works very beautifully on my system. That's what I realized here. And I understand Python is also damn easy, but Go is as easy as Python, right? So try in your free time. It's a cloud native language. That is something which I feel happy, because everything that you see on cloud native, right? Docker, Kubernetes, if you see their code base, everything is just written in Go, right? So all your cloud is all written anyway. Your containers and all, everything is written in Go. Then why not we can't write, right? It's as simple. So okay, how Go is written in Go, guys. This is a simple discussion about it. When I went about Go, right, I'm more interested in how does the Go compilation. Uh, is it audible? Hey, I think there's an echo, right? Uh, okay. When I was just going through Go, right, I was far more interested in how does the Go compiles. Then I went ahead and get into the GitHub repo, figure out the compiler package to how does the Go compiles, right? And I was highly amazed with one fact that the whole compiler was being written in Go. I did not understood that how can you write the same programming language in the same way which is going to read your code, right? So for me, it was new. I am sure a lot of us will be aware of it, because C plus C and the Turbo C and all those languages are being written in C only. But I did not know. Okay, so Go is written in Go. How does that they do it? Just a walkthrough. Initially, they have written the code in C. Okay, and then you bring up the minimal runtime and garbage collection. So that's a minimum requirement, right? You will have to bring up the initial module of Go at least in C, because C is the only language through which you talk with assembly, and assembly goes and sit into the machine code, right? So C is the only language which is being highly close to assembly. We guys can't code in assembly language, right? If you tell me to code in microprocessor 8085 and all that language, I cannot code, right? So you need some English level programming where comes C, and then on top of it, you initially write in C through memory references and all those pretty standard concept, and then what you do is you bring up that particular compiler. So now you have a very sub-module part which is up, which is being written in C, which is able to read your extremely miniature part of your Golang syntax, not the complete, guys. It's a very small. If I went through the initial compiler, what I realize is the only thing which is it is able to do your read your fun main. It is not very small part of it. And with that compiler, I was able to get the memory reference also, right? So this is the whole thing. Okay, this is what the compilation happens with Go, right? Go and dig into the GitHub repo, right? Figure out if you're really interested, how does the compiler works. I know a lot of folks like us work on the business use case more rather than creating a programming language or getting into compilation. But just go through it. As a software engineer, right? We should always go through a compilation code, guys. And that's where the fun begins, right? That's where the whole programming stuff begin their journey in software world, right? So compilation is all. How many of us have read at least one compiler code in detail? You have read, right? Which one? Sorry.
It was a college project, so we written a compilation code for this, and we tested it, and we deployed that. Yeah. It was a intra college project, so we did that.
That sounds really good. So right. So typically, majority of us would have not written compilers and all, right? Because we don't need to. We are at the use case side of it rather than at the creation side of it. But since I wanted to get deep into Go, right? I just went through it a typical compilation. So initially, what given any .go file to a compiler, right? What typically it really happens is it start tokenizing. That's a standard compilation technique. It always keep tokenizing, and then once it tokenize, right? It basically, the whole agenda of that particular component is to create a AST. We call it abstract syntax tree, right? That's the whole funda through which your code will start getting parsing. And that's we typically called in compilation technique, right? Those teams, they typically call it front end for compilers. So that's a different team. If you sit with any compilation team, you will know that how they have divided the structure of a compilation techniques. So they call it front end for compilation, these two modules. Okay, then these are the package name. The fourth one, what you see, right? Code optimization. This is where the most of the people time goes in compilation. So here what I'm doing is I have some code which is being written. Now I want to optimize that compilation techniques. When I say optimize, literally means that I want to make a method inline. Say it is being jumping from 1 to y, bring that y back to x, right? So inlining a function, removing a dead code, right? And there are a lot of things. There are hundreds of things which really happen, because when I went into their code base, to be very frank, I did not understood what was happening. I needed someone to help me out in that code base. But there are a lot of things which they do it in code optimization. And when I spoke with one of my friend, right, who worked for there, he said, yeah, typically it took us a span of 1 year to just write that module. Right? So that big it is. And then the final one, which is the real magic, right? You have a low level optimization, and then finally the assembly language that comes up, and the assembly to finally your machine code language. So when I say machine code, it literally means two processor architecture. The whole world of machine codes is just divided into two architecture: 8086 or RISC processor, ARM processor. Right. So whatever you do on a software, eventually going to sit in one of these machines only. So as long as I'm going to encode or decode that particular programming language or machine codes, I can get anything run. That's the fundamental of any software running. Right. So yeah. Okay. Now, do I have to cover this slide? How many of us know Android architecture here? No. Okay. Okay. Let me quickly take it, guys. Where is Kiran? Kiran. Oh, I think I can't see Kiran here. Okay, so probably, yeah, I'll take 15 more minutes, guys. Okay, so how does the Android works? So you have a source code which you have written in Java. A typical Android mobile app in your system is actually a Linux process, nothing else. It's a Linux process, isolated Linux process, where one process does not talk or does not meant to be have a conversation with other Linux process. Right? Android is a trimmed version of a Linux, basically. Right. And what really happens under the hood, you write code in Java. So we guys at the Android side, right, we code in Java or any bytecode compatible language. You give it to Java C, convert that language into the bytecode, right? Oh, sorry. Right. Once you get a bytecode, then we have a tool, something called as Dex tool. And this tool is something which will take all your bytecodes and do a compressed zip version of it and run it on your machine, on your mobile phones. As simple. So whenever somebody tell you, right, that how does this app is working, just give a gyan of Dex. Dex is the whole key creator in Linux process, which is basically making your run, because it is the tool which is actually converting your bytecode and getting into the machine code on those processors. So if your mobile phone is made up of 8086, the 8086 instruction will start running, Intel. But now I do not see any company which generates 8086 processor on mobile phones. Everyone is ARM, right? So ARM means, what does ARM stand for, guys? Any idea? You? ARM stand for basically advance. A stands for advance. R stand for RISC. And RISC internally stand for reduced instruction computer set architecture. And M at the end of ARM stands for machine. So ARM is a RISC-based architecture system, right? And okay, so this is all about my a slight overview of compilation and how Kotlin works, right? So whenever people see Android code base, we all see Kotlin nowadays. I'm sure the folks who worked on React Native and all will know, right? So why does the Kotlin turned up in the story, right? We were very happy coding in Java. Suddenly I see in 2015 and all that time, Kotlin came up, right? Do anyone knows that what was the Google theory to bring Kotlin and remove Java in its ecospace? Any idea? Okay. Probably you must have heard it. You may not remember. It's a very long story which happened in the federal court in US, where Oracle made a sue against Google, saying that you have done an infringement on our code. So you know, right? Java history. Just to give you a slight glimpse, Java comes from Sun Microsystem, right? And then Sun Microsystem, Google had a great relationship with Sun. Then Sun Microsystem got acquired by Oracle, right? Then Java versions became some were free, some were paid. All the XYZ happened, and then from that point, right, Oracle sued a case in the federal court saying that you guys, Android, have did the infringement right on our copyright code base, and that case lasted for around 4 or 5 years, pretty long. At the end, what really happens is the federal court jury members, right, they gave plus heads up to Oracle, saying that, yeah, what you are saying is right. Google have actually taken an infringement. Right, from that point time onwards, Google started thinking about it that I want to get away from Java monopoly. And then that's how Kotlin turns up. Kotlin is also a beautiful language which basically takes any Kotlin file and converts into a Java compatible bytecode. right? That's the whole USP of Kotlin. And Kotlin is being created by JetBrains, which is the big baba of all your IntelliJ and all that stuff, right? So, okay, just a quick overview of Android architecture here. At the bottom, red color, what you see is a Linux kernel. This is where all your drivers will go in and sit in Android process, right? The whole platform code, if you go and see sometimes of Android, you will realize that at the bottom layer, every code is being written only in C. That's where the drivers are being written. Then you have on the top, you have HAL, hardware abstraction layer, where people have written their standard library to connect with the lower level drivers and all. So you have a camera, you have a OpenGL, and a lot of other XYZ stuff. Then on the top, you have something called as the core C++ library, OpenKit, WebGL, and all the stuff, where I have worked for many years. Right. And then on the top, you see a system apps. So from a user point of view, what you actually see on a phone is only the system apps. Right. So, but under the hood, we are talking with all across these layers, and it happens across every process. Okay. So. So here comes the main core part of it, right? React Native architecture. When I started taking my head into React Native in a very initial days, guys, right? I wanted to understand how somebody can. React Native came up with the approach saying that you write with my tools on JS with JS, and we make it run on Android and iOS, right? To be very frank, I did not understood this whole concept of running the same code base. It's not that I'm against it. It's just that I do not get an opinion of buying that. How can you make a JS code to run on a JavaScript core engine? A core engine, say a V8, which is running on your Chrome, or Hummies, any sort of JavaScript engine, is actually designed to slow down your systems. They take their own sweet time. So if you see any open source engine code, you'll realize a lot of parsing happens, a lot of interpretation. They slightly slow down your code. So I did not get an opinion or understanding how does somebody can make it work JavaScript on this. So initially I thought React Native is all about WebView. Okay, that was the whole understanding I understood. It's all basically rendering on a web view at the background. But that did not turn out. Then I have to go actually dig into the React Native code base of GitHub to figure out what they are actually doing. And I was really amazed with the way they have written the beautiful way of that. How does a JavaScript code, connects with your top layer via bridge, and then all those Android conversation or a Java conversation that really happens. So they have written a great platform code on both iOS and Android in their own native language. So it is something which is extremely tough task, if you ask me, right? So what they have done basically is anything that you create in your JS, they have a equivalent Java files residing in their platform code base. So if I say I want to create a edit text, they have a React edit text component sitting in the platform code base, right? And if suppose you are creating a view which is not being recognized, then they have created a generic template for view where they are trying to just create a view and throw it into the upper layer. So there's a lot of work, right? This is not something which I have seen in my career where people can actually take the JavaScript in a serialized format and throw it into the top layer and write all those upper layers, including both Android and iOS. Right, so that is where I felt that's amazing. And how did that happen? These what you see, right? Native modules implementation. This is where all our Android and iOS code has been written by React team, right? So this was an amazing work. And Yoga Engine, which was my area of interest. That how does a Yoga Engine actually work? So you code in your JavaScript, but the top layer, everyone only understands Java compatible, right? So how does that Yoga is actually playing its game? Then I read about flex layout in JS and all that. How does a flex layout when you code, right? What they have written the patented way of communication from the bottom layer layouts to the top layer layouts by extracting those components, right, and giving it into the Yoga engine of how does the conversion actually happens at runtime. This is something which is very probably at some point, right? I want to take a session maybe sometime later, saying that how does the bottom layer actually connects with the upper layer, right? Any doubts here in this? You're good, right? Okay, let me go it quickly next. And bridge concept, right? This is how the React Native is working fundamentally, right? Anything that you code in JavaScript, and you suppose you have not that API which is not being available, then you have to anyway code in Android, their native language. But how does that really works under the hood is you have a bridge where JavaScript have written the basically the engine where it takes away all your JS code, runs it into the mobile engine browser. They typically called Hermes is what the name, but they were initially using V8 and JavaScript core engine and all. But it takes all your JavaScript code, compiles it, put it into the bytecode, into the machine code, and create a R file out of it and give it to the framework level. Right. So that is there are a lot of things which is happening under the hood, and this is something I was amazed that they are actually not using WebView in any of their code base. They are actually compiling and bringing it down the exact native, and that's where the speed comes fast. But the big disadvantage for which I did not like React Native is just because the power. Anything that you do from lower layer to top layer, right? Every time when you load up your app, power. You take any milliampere device and connect it with your mobile phone, you realize the graph literally shoots up, right? So for that reason, in our previous company and all, they stopped using it, saying that power goes away. When right? Yeah.
We are having V8 engine, right? So it's a top layer. That internals we are going inside the very deep. So they are having separate engine for running this native code. Is it?
They do have separate SO files, typically the engine files. So that's why if you see, right, the whole React Native from pretty long, almost 5 years back, they understood this problem and they were trying to move into that turbo and fabric architecture, right? That's where the whole concept turns up. That, but they did not highlight anywhere in the forum where power is a concern. But the whole issue turned up from the power, right? Anything you do serialize and send it back to the top layer, how much, what layer are you trying to async? Very difficult, right? But in the new architecture, what they're saying is we will give you a tool through which you can directly connect with C code by taking a direct reference. That's where they are bringing the USP, right? So that no communication between the layers. Right. So this is the native. Okay. This is the way how this is a tech part of it, code part of it. You initially, when you want to communicate across the from your JS to Android, right, you have to create a native module. That's a basic template. Then you have a native package. Then you have a native application. I'll just quickly show you the code block diagram. So initially, when I wanted, I ended up creating a native module in my Kotlin code base. Then native module is what go and sit inside my package. Package is what being called from my application part, and that's how the bridge comes up and takes the control from here onwards. So this is what being exposed to me as an app user, right? You create a module, put it into the package, throw it to the bridge. Bridge will send the data, whatever you are trying to send it to this guy, deserialize it at the JavaScript layer, send it back as and when. So the whole communication, right, happens via JSON serializing. And it's not a typical JSON serializing. They have trimmed the whole concept of JSON for me because they have highly optimized the JSON part of it. Okay, that not typical JSON. They have highly optimized based on the use case of that. How do we trim the versions before sending the data to the top layer or from top to bottom? Right. So and here comes the CPU architecture. Right. You have an ARM. You have a 8086. Now these are the fundamental thing, right? When you have a RISC-based processor, which is what being running on all your mobile phones, right? You have a simple instruction set which is being given to a CPU cycle. So one CPU cycle typically execute one instruction set. But in CISC, right, complex instruction set, what literally happens is multiple instructions get executed in a typical one single CPU cycle. So if you see, right, on our normally laptop and all, most of the configuration will be based on 8086, right, Intel-based processor. Right? Why? Because first of all, they are fast. They can execute multiple things, and they are not software dependent. CISC depends heavily on hardware, but RISC-based processor, which is being powered on your mobile phones or on your IoT devices, or on your fridge, watches, Samsung. I mean, washing machine, anywhere where, right? Everyone use RISC because that is a simple instruction set that is being designed to work with software. It takes less power. That's the whole USP for which. This guy RISC took a highly, and even now you see on Apple and everywhere, right? They are shipping only with RISC-based processor, right? So, but they are expensive. Normally, RISC-based processors slightly expensive, right? So, okay, this is just I'll skip this slide, right? And then, just the communication which I wanted to explain here, right? That how does the Go code actually is talking to other lower layer, right? So when I took a Go code, what literally happens, right? It gave me a .so files. So do we understand SO files, guys? Here? No, okay. So SO file is basically the way through which system, one programming language want to connect with another programming language, That's the whole reason of SO files. And SO files is not typically mobile nomenclature. It resides in across multiple different forum. Okay. So SO file typically say that if Java wants to talk with C, right? What is a way to through which you can communicate? So they create a library and all that XYZ funda where they push your Java code into this native C, and from there onwards the pipeline follows. Right. So here, what I wanted to show you is basically Java native interface, JNI. That's the whole backbone through which any technology can communicate with anything else. When I say any technology, at the left side, it's always Java or Java compatible bytecodes. On the right hand side is basically any language which can generate machine codes. It can be C, it can be C++, it can be Go. For that's it. Right. Okay, what kind of tech can run on Android, right? So a lot of people get confused here that what can I actually run on Android? So one is your Java compatible bytecodes, right? Any process or any system which can generate me Java compatible bytecode, I can make it run on Android. Okay, along with the framework dependency. Obviously, you need a framework dependency. If the framework code is not being sitting to talk with Java to Java, you can never make it work, right? So you need a framework dependency. The second one, right? Any language that can generate machine code of 8086 or ARM will be able to run. And that's where the React Native lies here. React Native lies fundamentally on this principle that whatever we do, we will make you generate instruction code for those processor, right? And that's where Go is also trying to do the same thing. So this is a fundamental. Right. And okay, so this is one of the tool which I use. Okay, Go Mobile is a tool in basically it's a package in Go world where through which I can take any Go code and create those instructions, right? 8086 or ARM based processor and make it run on my mobile phones. Right. So I will not go through detail about this. You just have to, if you are interested, right? You just have to Google it out that how does the Go Mobile actually works. But what I will show you, right, is something. In this code, right? What I'm trying to do is this is a Go code, guys, right? Just VS code is what the typical editor which we use. So here I have imported one, but a few packages. What you see in the first line is import, typical package. Then you have a fun main, right? And then I have a simple print statement operating anything, right? And then at the bottom, right? What I wanted to do is I have written a code of SHA. Basically, just give me any string, encode it into the SHA. Typical programming code, simple, right? Any string encoded into the SHA. And this is the code which I wanted to call from my JavaScript world, right? Via Android, right? And look at it. How simple is it to read and all, right? Go. The syntax is pretty straightforward. It just, I mean, looks to me more like a Python wala logic. What I did here at the bottom, if you see, right, there is a Go mobile command which you see at the bottom. This particular, just a command here, which basically lets me convert this particular stuff of Go into the machine codes. Now, how did that happen, right? So what literally it went ahead and did is the moment I ran this command, right, it created a R file for me. What you see here, this Android sha.r, this is the file which it has created for me. Now, what this file actually contain? This contain all your instruction set that I can make it run on Android. That's the whole magic of this tool. So I just wanted this, basically. The moment I get this, I know how to get my job done on Android, right? So what I did is, I will show you my, this is my Android Studio code running on an IntelliJ, right? So what I'm trying to do is, right, how did I call this API? If you see in my Go module, right, I want to call this API, call Go. So this is the bridge which I have written. I will not go through the bridge code, but what I'm trying to tell you, this particular code will be called from JS files, JavaScript, right? And then when I call this, right, here, this API, if you see SHA, right, mobile.sha, this is not being written in Java, neither being written in JavaScript. This is being written in Go, what I showed you. And how is it coming here? What I did, right? If I show you my libs folder, under the app, you see libs. Here you see that particular R file, which I generated via the tool. I copy pasted the tool in my libs folder, linked it, And then I started exploring that what this R contains, right? If I double click on this, right? So you can do double click of R file only in Android Studio, guys. VS Code does not support it, right? So if you want to see the content of R file, you will basically have to put that file in your Android Studio and then see what. So where is this magic happening? So if I show you this JNI, right? See here at the bottom, you see the two types of processor which is coming here, right? ARM and 8086. These are the ones. This is where the actual magic happens. Okay, so the moment I see this, you see there is a SO file. Now this is the file which is actually responsible for talking from my Kotlin code base to Go. Right, this is where the whole funs begins. So a lot of people know about that. How do we use Go mobile, but they did not know how is it actually being happening. So if the moment you see your R file, right, in Android, you will realize how does the communication happens. Right, so that's all from my side for this. I have not gone deeper into it because of time, but let me cover up quickly with my slide. Okay, what is it which I have left out, if any? All right. So yeah, just okay. This is something which is can be skipped. So when I was doing this experiment, guys, right, I wanted to understand the use case, right? So to figure out that is it really valuable in industry use case or not. Then I spoke with few guys, right? Then a lot of people said, yeah, we did not have any reason to use Go in Android or in React Native, right? Then luckily I got one guy from a startup where he said that yes, we used it in our project. I said, how does that work out for you guys? So what they wanted to do, na, anything that you want to do with hardware. Suppose you are trying to bring up new hardware which you want to connect it to your Android phones, and you already have a React Native tech running, right? When you connect with any new hardware, guys, the whole communication happens with byte buffer, right? Everything is byte, and the moment you want to do a byte communication, native always works to be a better approach rather than coding in Java, right? So in his case, and wherever you want to directly talk with in terms of byte buffer, this can be a better approach compared, because if he did not have a Go, he would have chosen to use C to get his job done of new hardware. But he said, yeah, Manish, I do not have a the current workforce in his company was not interested to learn C, but they were really interested to learn Go. Okay, so they went ahead with Go and got this project pretty much into the production. Right. So, remember, whenever somebody talking about any native language communication, you will have to understand that the results are not immediate. Because why? Because whenever you talk from one language to another, guys, right, there's always a layer of communication that happens. This will always slow down your system. Right. So you should understand that if you need an immediate result and you are making your user wait, this is never a good approach. But whatever work you're trying to do silently under the hood without blocking any visible component of UI, this works very well. Right. So this is all about me. All right. That's it, guys. Hope this was okay. Thank you.